Today we will discuss the topics in second module, and the first topic is time response. The time response of a system is the output of the closed loop system as a function of time, and the time response can be obtained by solving the differential equation that governs the system, and the time response is denoted by C of t. Suppose there is a closed loop system and its input is R of S and output is C of S, and the open loop gain of the system is G of S and the feedback gain is H of S. In this type of systems, we can write the transfer function as output divided by input, that is C of S divided by R of S is the output transfer function, that is C of S by R of S. And we can find that this transfer function will be equal to the loop gain. Here the loop gain will be G of S divided by 1 plus G of S into H of S. So for the closed loop system, the transfer function will be C of S by R of S, that is equal to G of S divided by 1 plus G of S into H of S. Let that quantity be M of S. So this gives the response in this gives the transfer function in S domain, and the corresponding response, that is output in S domain, is C of S. And we can write the C of S by multiplying the input R of S with the loop gain, that is C of S will be equal to R of S into M of S, and the corresponding response in time domain will be obtained by taking the inverse Laplace transform of C of S. So C of t will be equal to L inverse of C of S, that is equal to L inverse of R of S into M of S. This is the basic terms in the case of time response, that is we are measuring the response based on time. And the time response of a control system consisting of two parts, and that is the transient response and steady state response. We know that the transient response is the response of the system when the input changes from one state to another, so its behavior is unpredictable, and the steady state response is the response as time t approaches infinity. That means there is no change in the input, so correspondingly there will be we will get the response which are not changing. So it is called a steady state response, and that means the response as time t approaches infinity is called a steady state response, and the transient response is the response of the system when the input changes from one state to another. So the test signals used in the case of analyzing in the system are the basic standard test signals are step signal, ramp signal, parabolic signal, impulse signal, sinusoidal signal. These are the 5 basic standard signals, and in the case of step signals, the mathematical expression for the step signal is equal to R of t equal to 1 for t greater than or equal to 0, and it will be equal to 0 for t less than 0, and its diagram is shown like this. That means it will go to a step change at a t equal to 0. So its value will have a value a for t greater than or equal to 0, and here it is given the mathematical expression for unit step function, so its value will be 1. And if it is no, if it is a step signal, then we can represent the magnitude as a. And the next signal is the ramp signal. We can see that ramp signal is linearly increasing with the time. And the next is the parabolic signal, and it will go to the shape of a parabola. So next is the ramp signal. The mathematical representation of the ramp signal is R of t equal to at for t greater than or equal to 0, and will be equal to 0 for t less than 0. In parabolic signal, the mathematical representation of parabolic signal is R of t equal to at square by 2 for t greater than or equal to 0, and is equal to 0 for t less than 0. In all these cases, we are considering that for t less than 0, the signal value will be equal to 0. Signal has value only after t greater than or equal to 0. Next is the impulse signal. The impulse signal is denoted by the letter del of t, and mathematically it is expressed as del of t is equal to infinity at t equal to 0 and equal to 0 for t not equal to 0. Also, integral minus infinity to plus infinity del of t into dt equal to a, and figure shows the impulse signal. You can find that the impulse signal has got a value when t equal to 0. That means it is it looks like a pulse, and but actually actually this impulse signal is practically not possible. So we are assuming that the impulse signal is a pulse signal with a short duration, that is it has a duration of 1 by delta. Whenever that 1 by delta approaches 0, then it will become exact impulse signal. And next we should know the Laplace transform of basic signals. Step signal has got a Laplace transform. Unit step signal 1 has a Laplace transform 1 by s. If its amplitude is a, then it has a Laplace transform a by s. And next is ramp signal. And in the case of ramp signal, signal can be represented as at, and its Laplace transform is a by s square. Similarly, in the case of unit ramp signal, it has got a t, and its response is Laplace transform is 1 by s square. And in the case of parabolic signal, and the equation is at square by 2, and its corresponding Laplace transform is equal to a by s cube. And in the case of unity parabolic signal, its time domain equation is t square by 2, and corresponding Laplace transform is 1 by s cube. In the case of impulse signal, it is represented by del of t, and the corresponding Laplace transform is 1. So next topic is order of a system. The order of a system is given by the order of the differential equation governing the system. We know that a system can be represented by differential equation. Sometimes it may be represented by nth order differential equation. So in that case, order of the system is n. And if the system is governed by nth order differential equation, then the system is called nth order system. And we can represent this system by the transfer function as T of s is equal to P of s by Q of s, and P of s is the numerator polynomial and Q of s is the denominator polynomial. And usually we can represent a T of s as P of s by Q of s, that is equal to s plus z1 into s plus z2 plus etc. up to s plus zm divided by s plus p1 into s plus p2 etc. up to s plus pm, where z1, z2, z3 are the zeros of the system, that is in the numerator polynomial, and p1, p2, p etc. up to pm are the poles of the system, that is in the denominator polynomial. And the order of the system is given by the maximum power of s in the denominator polynomial q of s, and also the order is given by the number of poles of the transfer function. And usually the zeros and poles are critical values of s, and it represents the values of T of s when it attains 0 value and infinity value. When s takes the values of a 0, then the transfer function T of s will become 0. When s takes the value of a pole, then T of s will attain the value of infinity. See, if s takes the value of a 0, that means s is equal to minus z1, then T of s will become 0. You can see that. When s takes the value of a pole, that means s is equal to minus p1, then T of s will become, denominator will be 0, so T of s will become infinity value. So see, once the function becomes 0, it represents a 0. Once the function represents the s value is 0, that means the transfer function will become 0. And once s value is a pole value, then the transfer function will become maximum value, that is infinity. Okay. Next is the response of the first order system for unit step input. So we are considering the first order system, and we are giving a step input to that system. So what will be its response? That is our consideration. So let us consider a first order system, and it is a unity. Here the system is a unity feedback system, and here the input and output are marked as R of s and C of s. You can see. So the feedback is a negative feedback system. So the loop gain of the system will be, you know that once G of s is the open loop gain and H of s is feedback, in that case loop gain is G of s divided by 1 plus H of s into G of s. Similarly here, instead of G of s we are using 1 by Ts, and instead of H of s we are using 1. So its loop gain will be 1 by Ts divided by 1 plus 1 into 1 by Ts. So that we will get a value 1 by 1 plus Ts. So that is shown in the right side, that is R of s is given to the loop gain 1 by 1 plus Ts, and the output is C of s. So we can see that R of s is input and C of s is the output, and the closed loop transfer function of this first order system is given by output divided by input, that is C of s by R of s, that is equal to loop gain, that is 1 divided by 1 plus Ts. And here we want to find out the response when we are giving unit step as the input. So if the input is unit step, then input is R of s, that is the S domain representation. Correspondingly R of t is the input, time domain representation is R of t. So when it is unit step, R of t will be equal to 1. When R of t equal to 1, R of s will be equal to 1 by s. You should know the Laplace transform of unit step function. Laplace transform of unit step function is 1 by s. So R of s equal to 1 by s. So the response in S domain, C of s can be found out by multiplying R of s with 1 by 1 plus T of s. So C of s will be equal to R of s divided by 1 plus Ts. So instead of R of s, we can substitute the value 1 by s. So that will be equal to 1 by s into 1 divided by 1 plus Ts. So we can take t outside from the denominator side. So we will get 1 divided by st into 1 by t plus s. And we are taking t outside in order to make the quotient of s as 1. Then only we can take the inverse Laplace transform easily. So this form can be written as 1 by t whole divided by s into s plus 1 by t. So in the next step, we want to find out the response in time domain. So for getting the response in time domain, we have to take inverse Laplace transform. Okay. So before taking the inverse Laplace transform, we have to use partial fraction expansion. So C of s will be equal to 1 by t divided by s into s plus 1 by t, that is our original form, and it can be written like a by s plus b by s plus 1 by t. This is the way to get a inverse Laplace transform. So here a can be obtained by multiplying C of s by s and setting the s value equal to 0. So it is given in the next step, a will be equal to C of s into s at s is equal to 0. So instead of C of s, we can substitute 1 by t divided by s into s plus 1 by t, and that is multiplied by s, and again s and s will be cancelled out. After that we will get 1 by t divided by s plus 1 by t. In that we can substitute for s as 0. So we will get a 1. That means a will get a value of 1. The next term is b, and to find out b, we have an equation. B will be obtained by b is equal to C of s into s plus 1 by t at s is equal to minus 1 by t. So instead of C of s, we can substitute 1 by t divided by s into s plus 1 by t. So s plus 1 by t will be cancelled out from the numerator and the denominator. So we will get a 1 by t divided by s at s is equal to minus 1 by t. So we will get a value of b as minus 1. So we can substitute the value of a and b into the equation for C of s. So we will get a C of s will be equal to 1 by s minus 1 divided by s plus 1 by s plus 1 by t. So now this we can find out the inverse Laplace transform of this C of s easily. So C of s is equal to 1 by s minus 1 by s plus 1 by t, and the response in time domain is given by C of t, that will be equal to L inverse of C of s, that is equal to L inverse of 1 by s minus L inverse of 1 by s plus 1 by t. L inverse of 1 by s is equal to 1, and L inverse of s plus 1 by t equal to e raised to minus t by t. That means the general form of Laplace transform e raised to minus at equal to 1 by s plus a. Instead of a, here 1 by t is coming. So we can substitute for a as 1 by t. So we get the time domain response as 1 minus e raised to minus t by capital T. And the equation 3.13 is the response of the closed loop first order system for the unit step input. And for step input of step value a, the equation is multiplied by a. So for the closed loop first order system, unit step response is 1 minus e raised to minus t by tau. But for step response, it is a into 1 minus e raised to minus t by tau. So we can plot the response for various values of t as t equal to 0, t equal to 1t, t equal to 2t, t equal to 3t, etc. up to t is equal to infinity. So we get different values of COT. You can substitute for t equal to 0. So you will get 1 minus e raised to 0, that is equal to 0. When t equal to 1t, you will get e raised to 1 minus e raised to minus 1. That value is equal to 0.632. Again, you can substitute other values such as 2t, 3t, etc. You will get different values. At a stage t equal to 5t, you can find that its value is 0.993, and after that it will be getting the same range of values. That means at a t equal to 5t, the system attains steady state. Okay, that means you can see that the input is at t equal to 0 is 1. That means it suddenly changes the state from 0 to 1 at t equal to 0. So, but that change appears in the first order system in a slowly manner, in a slower manner. That means the response will attain the one value when t equal to 5t. That means there is no sudden change from 0 to 1. There is a slower change or exponential change from 0 to 1. That is how the first order system responds to a unit step function. See, ഇവിടെ എന്താ പറയുന്നതെന്ന് വെച്ചാൽ യൂണിറ്റ് ഫസ്റ്റ് ഓർഡർ സിസ്റ്റമാണ് നമ്മൾ കൺസിഡർ ചെയ്യുന്നത്. അതിൻ്റെ റെസ്പോൺസ് ഒക്കെ പറഞ്ഞ് നമ്മൾ ഫൈനലി നമ്മളൊരു റെസ്പോൺസ് കിട്ടി നമുക്ക്. അപ്പോൾ അതിലെന്താ മനസ്സിലാക്കേണ്ടതെന്ന് വെച്ച് കഴിഞ്ഞാൽ നമ്മളൊരു യൂണിറ്റ് സ്റ്റെപ്പ് ഇൻപുട്ട് നമ്മൾ അങ്ങനെയുള്ളൊരു ഫസ്റ്റ് ഓർഡർ സിസ്റ്റത്തിന് കൊടുക്കുമ്പോൾ അതിന് കറസ്പോണ്ടിങ് ആയിട്ട് കിട്ടുന്ന റെസ്പോൺസ് ഒരിക്കലും യൂണിറ്റ് സ്റ്റെപ്പ് അല്ല. അതായത് ഇവിടെ സഡൻ ആയിട്ടുള്ള t equal to 0 എന്നുള്ള പോയിന്റിൽ 0യിൽ നിന്ന് 1ലേക്ക് ഒരു സഡൻ സ്റ്റെപ്പാണ് ചേഞ്ച് നടക്കുന്നത്. പക്ഷേ കറസ്പോണ്ടിങ് ആ ഫസ്റ്റ് ഓർഡർ സിസ്റ്റത്തിൽ കൊടുക്കുമ്പോൾ ആ ചേഞ്ച് അതേപോലെ കാണുന്നില്ല. പകരം എന്താണ്, ഒരു എക്സ്പോണൻഷ്യൽ ചേഞ്ച് ആണ് കാണുന്നത്. സ്ലോലിയാണ് അത് 0യിൽ നിന്ന് 1ലേക്ക് എത്തുന്നത് എന്നാണ് പറയുന്നത് യൂണിറ്റ് സ്റ്റെപ്പ് ഇൻപുട്ട് കൊടുക്കുന്ന സമയത്ത്. ഓക്കെ, അതാണ് ഈ റെസ്പോൺസിൻ്റെ ഇമ്പോർട്ടൻസ്. നമ്മൾ അതാണ് സ്റ്റഡി ചെയ്യുന്നത്. എങ്ങനെയാണ് ഒരു ഫസ്റ്റ് ഓർഡർ സിസ്റ്റം ഒരു സ്റ്റെപ്പ് ഇൻപുട്ട് കൊടുക്കുമ്പോൾ റെസ്പോണ്ട് ചെയ്യുന്നത്. സഡനായിട്ട് റെസ്പോണ്ട് ചെയ്യുന്നില്ല, പകരം സ്ലോലിയാണ് റെസ്പോണ്ട് ചെയ്യുന്നത്. ഓക്കെ, സഡനായിട്ട് 0യിൽ നിന്ന് 1ലേക്ക് ഒരു ചേഞ്ച് വരുന്നില്ല, പകരം എക്സ്പൊണൻഷ്യലി ഉള്ള ഒരു ചേഞ്ചാണ് വരുന്നത് എന്നാണ് ഉദ്ദേശിക്കുന്നത്. അതാണ് നമ്മൾ അനലൈസ് ചെയ്യുന്നത്, എങ്ങനെയാണ് റെസ്പോണ്ട് ചെയ്യുന്നതെന്ന്. ഓക്കെ, ദാറ്റ് ഈസ് ദി എൻഡ് ഓഫ് ദിസ്. നെക്സ്റ്റ് വി വിൽ ഗോ ടു ദി ടോപ്പിക് സെക്കൻഡ് ഓർഡർ സിസ്റ്റം.